3 is separation of variables. So being able to separate the variables, basically integrate, to go from having a dy dx equation to just going to having a regular y equation, an xy equation, okay? So equations where all x terms can be collected with dx and all y terms with dy are said to be separable. The solution procedure is called separation of variables. We've done a little bit of this already. A differential equation will be in the form of dy dx equals f of x times g of y. To solve, you must put your solution in the form of y equals h of x. So our goal in the end is to get it to a y equals form, or occasionally there's other forms that we leave it in. They're just more appropriate for the scenario than y equals, okay? So example 1, find the general solution for each of the following. So we don't have a variable to plug back in, or an ordered pair to plug back in. So when it's talking about the general solution, realize that there's going to be a plus c involved. Okay, that's the key. So let's start by separating our variables. How do we get y's on one side, x's on the other side? Okay. Basically multiply out the denominators, right? If we want to get dx to the other side, we're going to have to multiply by dx. If we want to get y out of here, we need to multiply by y. So we're basically multiplying both sides by y dx. Okay. With that in mind, on the left, the dx's cancel and you have y dy. On the right, the y's cancel and you have 2x dx. So we have separated our variables, yes? Once you have your variables separated, what are we going to do? We're going to integrate. Okay. What's the integral of y?
dy?
No. Go up in powers.
Y squared.
1/2 y squared, because we're adding 1 to the power and dividing by that new power, equals, what's the integral of 2x? X squared, because you add 1 to the power, and then when you divide by that new power 2, it cancels out. And then what do we need to say here? A plus c. Okay. Past here, it's getting it in a decent form. If we were to get y by itself, okay, you can multiply by 2. So then we're going to have y squared equals, and then that's going to be a 2x squared. And then, so I'm actually going to leave it as a plus c at this point, okay? So I mentioned this a little bit last week at some point on something. I remember mentioning it in brief passing, okay? The idea is the c, we don't know what c is right now. It represents some constant. We don't have any information to even find c. So a lot of times, it depends on the scenario, but you just kind of leave the c as a c. I will say in my notes, this technically was originally dubbed C1, if you will. And then technically, is this a slightly different c? It's technically a different constant because it's been multiplied by 2, but yet we're not going to do anything different with it. Okay, so a lot of times I would just see that as plus c, and you just don't show that it's multiplied by something or anything like that. Okay, so what would you do? So there's 2 options from here. One option is if we solve for y, what would this become? It becomes a square root, right? What do you have to put in front of that square root? Yeah, so you could say that this is y plus or minus the square root of 2x squared plus, and I have it written in mine as c2. You could just have it written as C. We'll talk more about that when we go to find C. The other option for expressing this is that instead of solving for y, we have an x squared and a y squared term. Depending on whether the x squared term and y squared term are added or subtracted would depend if it's a hyperbola or an ellipse. Okay, if you guys remember anything about that from pre-calc. Okay, if it was x squared plus y squared terms, if they're both positive, then it's going to be either a circle or ellipse type object. If it was an x squared minus y squared or y squared minus x squared, it's going to be some type of ellipse where the two curves are going outward. In this case, I would have said 2x squared minus y squared. I think you could do it either way, yeah. In my notes, I have it written as 2x squared minus y squared equals C2. So that's just kind of flipping the equation around there. And this is where we don't know what C is. There is a little bit of flexibility as to what the exact answer is. Okay. Okay. So what about B? What's this going to look like if we're going to separate our x's and y's? Except I don't want my dy to be in the denominator.
Multiply by dx, divide by.
Does that make sense, guys? That we're going to multiply the dx to the right. To get the y squared to the left, we're going to divide by y squared. So dy divided by y squared equals dx. Are you guys okay with that? Now, I am going to say, before I integrate it, what's another way to think about a y squared in the denominator? Right. So I would think about this as y to the negative second dy equals dx. I think you'll have more success integrating that way. Now, since we've separated our x's and y's, we're ready to integrate. What are we going to get when we integrate y to the negative second? Okay. Add 1 to the power, which makes it negative first, and then divide by that power. I just multiply it, so negative y to the negative first equals, what about the integral of dx? X. And don't forget a plus c. Now, on this, negative y to the negative 1, what is that? That's the negative of 1 over y equals x plus c, correct? No, because we're not integrating again. If we integrate again, yeah, we're looking at natural log, but we're not integrating again. If you're going to solve this for y, you want y out of the denominator, so you're going to have to multiply y to the other side. But then that x plus c, we need it to go back to the other side, so we're going to divide it. So how about y equals the negative of 1 over x plus c? Can we see that, or do I need to show that more? Okay. Okay, ready for C? dy dx equals xy. Separate those x's and y's, and we're going to have what?
Y over y equals x dx.
I'm okay with that. You guys okay with that? Multiply the dx over to join the x. Divide the y back to have it under dy. Thoughts on the integrating here?
Natural log of y equals 1/2 x squared.
Okay. So it's 1 over y, right? If you try and put it as y to the negative first, then you add a power, you're at y to the 0, and that's where my brain says, oh, crud, I did the wrong thing. Integral of 1 over y is natural log of y. Technically, it's natural log of the absolute value of y. And then the integral of x is going to be the 1/2 x squared plus c. Okay. We've got to get this in y equals form.
Something to do with E.
It does have something to do with e,
Um,
because natural log is base e.
Could be.
Is it e to the y on the other side?
Is it what?
Like, can you like divide by e so that then the e would be on the other side?
No.
Just be y.
No, because it's a base e. We can't separate the base by dividing.
Can you separate it by multiplying?
No.
it's something to do with like the power and the number, or the base and the number.
Yeah.
I
There's
don't remember what it is.
There's a couple different ways to teach this. I would maybe say left, right, middle. Because in other words, take us out of exponent form. Or, excuse me, take us out of log form into exponent form. And if I'm going to do that, the base is my left, yes. The left raised to the right equals the middle, which is the y. It's also, I had to see it before I could process it. It's also what some people would say is make both sides e to that power. And on the left, if you make it e to the power of natural log of y, it just becomes y, and then e to the 1/2 x squared plus c. Okay. Now, so I have one option of leaving this as y equals 1/2 x, whoops. I left off the e, didn't I? Important thing. E to the 1/2 x squared plus c. Okay, now, I'm going to tell you right now, that's not the typical way you'll see it in calculus. Okay, because as we go more to working with exponential equations, which I think is more, is it in 7.4? Oh, I think it's 7.4 when we talk about differential equations and growth and decay. Okay, so I'm going to throw in an or option, and this is where I'm going to introduce it, that this right here, y equals, so it's e to the 1/2 x squared, yes. Now, the plus c. I'm going to argue that this could be expressed as e times e to the c. Now, I'm kind of going backwards on something, so think. If we're multiplying e to some power times e to some power, what do? If the bases are the same, you keep the base and add the exponents, right? So I just undid that is what I did. And then what you will see, keep in mind, e is a number, yes? And so e to the c is some constant, e to the c is some number. It's not a number we know because we don't have an xy pair to find that particular piece. And so what you will see, making sure I'm showing the correct notation, is that they will use, instead of an e to the c, 1/2 x squared times, and they'll use k. Guess what k stands for? K stands for a constant also. Okay, and it's what you will commonly see done with exponential equations. So the other option to write this is y equals k e to the 1/2 x squared. And again, that's kind of a, okay, getting you ready for lesson 7-4 type thing. Okay. Ready for D? 4y prime minus 3e to the x equals 0. What do you guys know about y prime?
dy dx.
Okay. So 4y dy dx minus 3e to the x equals 0.
Well, just add the 3
So 4y dy dx is equal to 3e to the x. And then,
divide the 4.
okay, not divide the 4y.
And multiply the dx.
Yeah, I'm going to leave the 4y and dy where it is, multiply the dx over. So 3e to the x dx. Okay.
Now can we divide the 4?
I would just go ahead and integrate here. I don't know that it's going to benefit me to have a fraction on either side. So I would go ahead and integrate. What's the integral of 4y?
Let's see, 2y squared.
Add 1 to the power, divide by the new power. Integral of 3e to the x.
3e to the x.
And don't forget,
Plus
plus c. Okay. If we solve this for y, okay, now I would divide by 2. So y squared is 3/2 e to the x plus, and I would just leave it as c. Again, in my notes, it's marked as the original being c1 and this new one being a c2. So y is going to equal what?
square root of 3
Plus or minus the square root of 3/2 e to the x plus c. Okay. I do have an OR option, and the OR option would be more along the lines of 3e to the x minus 2y squared equals c, something along those lines. Is it any better? Is it any worse? I don't know. Okay. It all depends on where you're going with this next, I guess. Okay. Ready for example 2? Find the general solution, all still general solution, so we get to next page, of the differential equation dy dx equals x squared plus 1 over 3y squared. So what are you guys doing? It ends up being cross multiplying, doesn't it? Okay. Multiplying dx to the right and 3y squared to the left. So 3y squared dy equals the quantity x squared plus 1 times dx. And then go ahead and integrate. Integral of 3y squared. Y cubed. Integral of x squared plus 1.
Third x plus x.
There we go. Okay, you're just integrating each term, right? Now, in terms of options here, what options do I have? One option, what could we do? Take the cube root. So y is the cube root of 1/3 x cubed plus x plus c. What's the other option I have here?
I think you did on A. Wait, no, that was squared.
Yeah,
I think that's it.
I mean, so the other option is, first of all, getting rid of the fraction. So they multiplied it through by 3. So if I multiply everything by 3, it's 3y cubed equals x cubed plus 3x. And I would just leave it as c again. Okay, you don't traditionally put 3c, it's just a different c. And then putting all the terms on one side and leaving c2 on the other side. So the alternative option that you might see would be 3y cubed. Check that. I said the right thing. 3y cubed minus x cubed minus 3x equals your constant. Okay. And again, I'm just trying to show you options to be familiar. Okay. This other page. You're talking about finding a particular solution. Okay? Now, particular solution just means they're giving you an ordered pair here to basically plug in and find your C value. Okay? We're going to start off the same in that we need to separate our variables and integrate. First of all, what do you know about e to the negative t? E to the negative t is where? A negative exponent is going to go to the denominator. So I would think about that first, that this is x over e to the t dx dt equals 1. Because for me personally, that helps me to be able to see to separate my variables a little bit better. Because what can I do to separate these variables? X and dx can stay on top, stay where they're at. How do you get e to the t and dt out of the denominators? Multiply them to the other side. And e to the t times dt times 1 is just e to the t dt. And that makes it not bad, doesn't it? We're going to integrate. Integral of x. One half x squared. Integral of e to the t. E to the t plus c. Now, one thing I haven't talked about, we're used to what? X being our independent variable and y being the dependent variable. We're also used to doing things like f of x, where x is defined as that. Realize, since this is dx dt, and this is x of 0, this is the idea of x of t. So t is our independent variable here, and x is more like what we usually think of y. Does that make sense there? Okay, so just before we go too much farther, because that means we're more going to be solving for y eventually, so to speak. Now, I'm realizing I kind of have this in steps in my notes, in that step 1 here was to separate the variables. We already know that, right? Once you get to this point where you have integrated, this right here is a good place. Okay, so this right here is, first of all, it's a version of our general solution, yes? is a version of our general solution. In order to find the particular solution, what's the ordered pair we have to plug in? We have the ordered pair 0, 1, where 0 is your t and 1 is your x. So let's do some math. 1/2 times 1 squared equals e to the 0 plus c. 1/2 times 1 squared is 1/2. E to the 0, anything raised to 0 is 1. And so then if you solve for c, 1/2 minus 1, c is going to be negative 1/2. Okay. So then step 3 is basically putting this together. So we had our general solution of 1/2 x squared equals e to the t plus c. What did we just say c was? Minus 1/2. Okay. From here, I don't know. Good. There's not a good way to put this. If we get x squared by itself, that's going to be, how do we get rid of 1/2? Multiply by 2. So if I do that, 2 e to the t minus 1. And that right there, you could go one more step and say x is the square root of that stuff. But that's what I have as the particular solution in this one. It's a particular solution because it is specifically the solution based on the ordered pair 0, 1, and it no longer has that plus c in it. Okay? So really very much following what we've already been doing. Yes? Questions I need to answer on that one? Okay. Let me know if I have questions I need to answer. I'm trying to keep things moving. Okay, 4. Find the solution of the differential equation that satisfies the given condition. Well, can we start by just getting them out of fraction form first? Because there's a slight difference on this one, isn't there? There's an x, y together, but I would start with, let's multiply your denominators away. So multiply the dx to the right and the xy to the left. Is that okay? So then I'm going to have xy dy equals 1 plus x dx. And I guess I'm just thinking, okay, how's my brain need to process this? Divide by x, yes. Can you see that better now? That was my thought, is maybe we'd be able to see it better. So keep the y dy where it is. Divide by x. You could say this is 1 plus x divided by x. And then dx. What about 1 plus x divided by x? How can I rewrite that?
1 plus x times x.
1 over x plus 1.
I would rather separate it like that, in that one denominator goes with both numerators, right? So 1 over x plus, what's x over x? 1, and then dx. Because now that gives me 2 individual terms that I can integrate. The integral of y is 1/2 y squared. The integral of 1 over x, natural log of x, plus the integral of 1 plus x plus c. I did use absolute value. I figured I did, but. Okay. Now what? Yeah. Now, once you get that plus c, we have the ordered pair 1, -4, right? 1's your input, -4 is your output. So, let's plug them in. So, 1/2 times -4 squared equals natural log of 1 plus 1 plus c. Okay. -4 squared is 16. Half of 16 is 8. Did I hear an argument about natural log of 1?
Yeah, I told you that's 5.
Natural log of 1 is 0. So that right there is going to go to 0. And we're going to be left with 1 plus c. So c is 7 if we do our magical math there. Now, we go and we put these two back together. Where are we at? 1/2 y squared equals natural log of x plus 7. What?
Do we have to
By 2
separate one?
Well, that's, so I do have it multiplying by 2 through. Okay, so getting rid of the 1/2, y squared equals, and if we multiply by 2, it's what? 2 natural log of x plus 2x plus 14. I'd be tempted to leave it like that, although I do have, what's the other option? Instead of y squared, you could say y equals what? Plus or minus the square root. Now, and I don't know that you'd have to. What's an option of what we can do with this 2 in front of the ln? It can go where? To the exponent. So this could be written as natural log of x squared and then the plus 2x and plus 14. So many different options of ways to write things, guys.
You have to.
I'm not saying you have to write as ln x squared. That's not what I'm saying at all. Now, I'm glad I looked at my notes right here. I would have skipped all over this. Naturally, we put plus or minus, yes? Okay. Whoops. Didn't mean to do that. Officially, only the negative works because in our particular solution, what are we looking for here? It equals a -4. So because our point was 1, -4, this is only the negative square root of natural log of x squared plus 2x plus 14. So
Well,
only negative because of 1, -4. And that right there. Or, okay, I'm going to tell you guys, go ahead. I am very possibly going to finish number 5 tomorrow. But I'm going to say go ahead and try the homework and see what you can do with it. And then we'll follow up tomorrow. We might have more questions than normal, I would think. But work through them, see what you can do with them. We'll meet tomorrow. Okay?
Not rubbing your belly.
And don't worry, 7-4 is definitely 2 days.
Great. Wait, isn't that the last one?
It is.